Okay, hello everyone. So we've already completed Ohm's law, drift velocity, about resistance, the factors on which resistance depends. So moving forward, first we'll discuss how can we connect resistors in series, how can we find value of current, how will we find value of potential difference, how to solve the circuit when resistors are in series. So we'll start with the derivation, that is very important, and then when how to solve the numerical part. Okay, so if we'll see in series, an electron travels like this, like electron starts from negative terminal, it will flow like this. If you can see in the given animation, then electron will come to the positive terminal. As soon as electron will come to the positive terminal, battery will again charge up the electron, and then electron will again travel in this loop. So if you'll see, suppose that from positive terminal current I is coming outside and the current I is flowing in the loop. So if you'll see, if I enters R1, then I current will also exit from R1, and similarly the current that will come outside from I, that is I, will enter R2, and from R2 again the current that will exit from R2 will be I, and the current that will enter R3 will be I, and the current that will exit from R3 will also be I. So if you'll see in series, if resistors are connected in series, current through all of them will be same. So in R1, R2 and R3, current is same in all these three resistors. Since there are no another connection between this R1 and R2 or R2 and R3. So if there is any other connection between two resistors, then they cannot be in series. Two resistors are only in series if there is only one wire connecting both of them. So from Ohm's law, if you'll see, the potential drop in R1 will be IR1, we will denote it by V1. The potential drop in R2 will be IR2, which will denote it by V2. And potential drop in R3 will be IR3, we will denote it by V3. Now remember, electrostatic force is a conservative force. So in a complete loop, total work done will be zero. So on the basic basis of this concept, remember that total increase in potential. So potential is increased by battery, that is V, will be equal to total decrease in potential. So potential decreased in R1, R2 and R3. So remember, when resistors are connected in series, current through all of them will be same. Remember this thing. And second thing is that total increase in potential will be equal to total decrease in potential. So if you'll see, the total increase in potential is V and total decrease is V1 plus V2 plus V3, where V1 is IR1, V2 is IR2 and V3 is IR3. So you have to remember this formula, that potential of battery, that is V, is equal to current released by battery into equivalent resistance. So basically if someone asks you what is the current that is being released by battery, so current depends on potential of battery and equivalent resistance of our circuit. So our next aim is to find out equivalent resistance. So total increase in potential is equal to total decrease in potential, that is V equal to V1 plus V2 plus V3. Putting value of V to be equal to I into R equivalent, V1 will be IR1, V2 will be IR2 and V3 will be IR3. Putting all the values in this equation, we'll get equivalent resistance to be equal to R1 plus R2 plus R3. So remember, if resistors are connected in series, then the equivalent resistance will be sum of resistance of all the individual resistors. And also remember this thing, that when resistors are connected in series, the potential drop is directly proportional to resistance, because current is constant in all the resistors. So if there are three resistors connected in series, and my question is, how will current change in all these three resistors? Then current in all three will be same. But if someone asks you what will be the maximum potential drop depend on which parameter, then remember V is directly proportional to I into R. Okay, V formula of V is IR. See, I is same, so more the resistance, more will be the potential drop. Now suppose for this question, there is a battery of 20 volt, there is 6 ohm resistor, 4 ohm resistor, 10 ohm resistor, and the question is find R equivalent, current, V1, V2 and V3. See, all these three resistors are connected in series. So equivalent resistance will be sum of all the resistors. It's 6 plus 4 plus 10, that is 20 ohm. And V will be equal to I into R equivalent. V is potential of battery. I is current released by battery. R equivalent is equivalent resistance. So putting value of V to be 20, R equivalent to be 20, current will be 1 ampere. So basically the battery is releasing 1 ampere current. So this 1 ampere will enter 6 ohm, exit from 6 ohm. Again 1 ampere will enter 4 ohm, exit from 4 ohm. Again 1 ampere will enter 10 ohm, exit from 10 ohm. So potential drop in first will be I into R1. Current is 1, resistance is 6, so 6 volt. Potential drop in second will be I into R2. So 1 into 4, that is 4 volt. And potential drop in third resistor will be I into R3, that is 1 into 10, that is 10 volt. Now if you'll see, the total increase in potential is 20 volt. And if you will count the total decrease in first will be 6, second will be 4, third will be 10. So 6 plus 4 plus 10 will be 20 volt. So total increase in potential will be equal to total decrease in potential. And also see in which resistor the potential drop is maximum. See, in 10 volt, in 10 ohm resistor, the potential drop is 10 volt. So potential drop is directly proportional to value of resistance when they are connected in series. Okay, now on the basis of this lecture, you have to submit an online quiz that is given in the YouTube description below, and also the link will be there with the message in which you have received this video. Okay, if you have any doubt, you can send me and please submit the quiz.